In this video, we will learn how to set up a reaction table called a mice table. These reaction tables allow us to keep track of how the reactants decrease and the products increase as the system establishes equilibrium. Now, most people call these ICE tables, where I equals initial, C equals change, and E equals equilibrium. I call these mice tables because the units are molarity. That's where the M comes from. I think this is an important distinction because later we will use similar tables to set up titration reactions. Only at that point, most of our tables will be millimole tables instead of molarity tables. In these examples, we're not going to do any calculations. We're just learning how to fill in the tables. It might seem obvious, but you want to make sure that you start with the correct balanced equation. Everything that fills into these tables is based on this balanced equation, and if there's something wrong, or it's backwards, or there is some other issue, then it throws off everything. So let's do that. We have 3NO2 plus H2O. I'm just going to leave off the phases for right now to make it a little bit cleaner. Goes to 2HNO3 plus NO. So that's our balanced equation. The next thing we're going to do is write the labels for the rows underneath this equation. I for initial, C for change, and E for equilibrium. And I want to make sure that I include the units. I always write the units like this. I'll put the units next to the I, and then just put an arrow because the units are the same for all three rows of the table. It just makes it a little bit easier so we don't have to write M by every value. We can just look off to the side and we know what the units are for this particular table. That's the basic setup of the table. Now we're ready to enter the initial molarities. If you are given values, enter them exactly as they're given. Don't multiply by the balancing coefficient. If you're not given a value for one of the substances, often that happens with the products, then enter the initial value as a 0. Right now, we're only filling in the top row. So we are given some information. Initial concentrations are 0.100 molar for NO2. So I just write that down as it's given, and 0.060 molar for the water. We're not given starting amounts for the HNO3 or the NO, so we just enter those as zeros. Next, we enter the change that occurs. This change is stoichiometric, which means the plus nx or minus nx follows the balancing coefficients. The change will always be a subtraction on the reactant side and an addition on the product side, because we're losing reactants and gaining products as this forward reaction proceeds towards equilibrium. So for NO2, my balancing coefficient is a 3. This is on the reactant side, so it's going to be minus 3x. For water, it's just a 1, also on the reactant side, so it's a minus x. On the product side, I have a 2 for the HNO3. I always add on the product side, so that's going to be a 2x. And then for the NO, it's just a 1, so this will be plus x. Probably the most common mistake that happens is not incorporating those balancing coefficients in the change row. Our last step is to add together the I plus C rows to give us the information for the equilibrium row. We want to make sure we write everything down, including the variables. So for NO2, we have 0.100 minus 3x. For H2O, we have 0.060 minus x. For HNO3, it's just 2x because we have 0 plus 2x is 2x. And for NO, it's just x. The importance of setting up these tables and getting the information for the E row is because we must have equilibrium values if we want to plug them into the mass action expression for K. Remember that Kc only applies at equilibrium, so we cannot enter initial concentrations into the mass action expression if the value we have there is the equilibrium constant. And that is how you set up a mice table. Let's try another one. We start by writing our reaction, NO plus NO2 plus H2O goes to 2HNO2. We set up our labels, ICE, and add our units. The next step, we enter our initial molarities. So we have a 0.100 for NO, a 0.100 for NO2, and a 0.055 for H2O. We're not given information for HNO2, so we enter that as a 0. Now we apply the stoichiometry of the balancing coefficients to the variables in our change row. For NO, it's a 1, so we write that as minus x. For NO2, it's also a 1, also minus x, and the same for water. Moving to the product side, we do have a 2 in front of the HNO2. So on this side, it's a plus 2x. Then we add everything together, I plus c, to give us the E row. So we have 0.100 minus x, 0.100 minus x, 0.055 minus x, and 2x. In this example, we're going to add a couple more steps. We're still going to set up and complete the mice table, just like we did before, but here we're also going to set up our mass action expression and enter the equilibrium information from the E row into the mass action expression. We're still not going to do a calculation, but we're going to take a couple more steps towards getting there. We're going to start by writing our reaction. N2 plus O2 goes to 2NO. Set up our labels, ICE, and our units. Entering our initial concentrations, we have 0.100 for N2, 0.100 for O2, and 0 for NO because it's not provided. Following the stoichiometry of the balancing coefficients to apply our change, we have minus x, and plus 2x. Our E row is 0.100 minus x, 0.100 minus x, and 2x. To write our expression for Kc, we have Kc equals NO raised to the power of its balancing coefficient, which is a 2, divided by N2 times O2. Now we enter the information from the E row, and that gives us Kc equals 2x, quantity squared, divided by N2, which is 0.100 minus x, times O2, which is 0.100 minus x.